Hey, we are Team 11. I'm Inab. I'm Shubha.
I'm Q. I'm Diamond. We are designing
Oasta baby!
Out of total Europe energy consumption, 40% is due to building industry, especially office and commercial building being highly responsible. While architects and engineers are trying to solve this issue by designing green buildings, several design objectives such as the prevention of view and daylight often conflict with maximum power output. Therefore, we are here to propose a PV product as a second skin facade. Using one axis sun tracking adaptive mechanism, the design has rotating PV tracker within a folding framework. It's a multi-purpose facade system that collects energy, balances daylight entering, provides sunshade, and vision comfort. By utilizing dynamic mechanism, the product can continually optimize its angle according to the position of the sun.
Let's see more about our design evolution.
The design process was based on the following criteria. Soft criteria focuses on multifunctionality of product, adaptability in different seasons, modularity and circularity. Hard criteria focuses on measurements, light material, efficiency and orientation of PV, sun shading, time of investment and return, lifespan of the product. The most important of these aspects is efficiency and orientation of PV in the design of our product. We realized that installing a completely vertical PV over a facade is not the best option, as the horizontal tilt is more effective in capturing sunlight. So the issue is dealt by creating a vertical folding framework with horizontal solar trackers staggered within. Based on this thought, we came up with 10 design ideas. Each design was analyzed using the Ladybug plugin to calculate the solar energy per unit area through the time in winter and summer. Then a design matrix was created by marking them with 11 different criteria, including efficiency. Although the scoring was rather subjective, this matrix helped us in deciding the final design.
Eleven, 8, 9, 10, 11, 12, and 1, 2, 3, 4, 5, 6, 7.
The design consists of a folding and rotating mechanism to move along with the direction of the sun. To make the mechanisms work and have the design function as a product, the following connections were explored and designed. The connection of the motorized system with the pulley and steel cable to the top rail. The rollers connected to the steel cable to make the frame fold automatically. The connection of the pulley to guide the steel cable. Fixed connection of the frame to the bottom rail, preventing the whole system to move. The connection of the bottom roller to guide the folding frame along the rail. The motorized rotation of the panels through gears. And lastly, the assembly of the PV panels with the screw connection.
Our research experiment is based on energy optimization of a busy office space with the application of Oasta PV. To measure the extent, we have analyzed two situations. First, before the application of product, and second, after the application of product on facade. Using voltmeter, energy consumption due to HVAC, AC, motors, servers, electrical fittings and appliances are measured. In the after condition, sun energy collected by the product is also noted using a photovoltaic meter. Comparing the energy outputs from the two situations, the energy efficiency is calculated and the enhanced performance of the room with Oasta PV is achieved. We have also observed the factors affecting user experience of the product that depend on individual behavior and usage patterns. Based on these factors, a data collection survey is done that features different types of users, provision of manual control to users, effective warning system on users, and provision of virtual knowledge of the product.
As a group, we think that the product is practical and simple solution. The design is not complex to understand or execute.
The folding technique in the design is quite user-friendly. It provides visual comfort to the users while shading. Not only the system is energy efficient, but creates a play of light and shadow in the interiors.
Moreover, the product follows a circular approach. It is easy to assemble or disassemble. It is easy to maintain because of simple screw connections used to attach PV to the framework.
Although we think there are some drawbacks too. While the adaptive PV system plays a crucial role providing solar shading, balancing natural light, view to the outside, it somehow lacks on the efficiency output.
In a half-folded condition, the PV panels on alternate sides capture more sun rays compared to the other alternate. This makes the efficiency of one frame lower compared to the other. But on the other hand, when the system is in open condition, completely flat or unfolded, the efficiency would go up.
Both of these conditions have different impacts on the other factors. For example, shading, daylight entering inside, and visual comfort to users.
So, those are the points that we could have improved. Also, the aesthetics could have been enhanced if we had more flexible framework.
Indeed, it was a challenge for us to get the best of each aspect in the design.